Hello, my wonderful students. I know you guys have missed me, and I have missed you guys too. So I'm excited to get back into it. Today we're going to be going over graphing cotangent. So last time we graphed tangent, and we talked about how the graph of tangent is the same thing as saying the graph of sine of x divided by cosine of x. Now I know you guys know your trigonometric identities, and you know that cotangent is equivalent to 1 over tangent, which is equivalent to cosine of x over sine of x. So if you guys will remember, we actually graphed sine and cosine, and using the graph of sine and cosine, we were able to get the graph of tangent. So for the graph of cotangent, we're going to be doing the exact same thing with the minor difference that cosine is now my numerator and sine is now my denominator. So let's go ahead and see what that looks like. All right, now as before, I'm going to go ahead and plot some of these points down. So let me zoom in for a bit. Okay, so now that we have our coordinate plane labeled, we can actually go ahead and start by, I'm going to start by graphing sine. So sine, as we know, begins at the origin. At pi over 2, it's at 1. At pi is back at the origin. At 3 pi over 2 is negative 1. And at 2 pi is back at 0, not the origin. The origin's over here, this should just be 0. So we have the graph of sine that looks a little bit like this. And we're also going to go ahead and graph cosine. So cosine begins at 1. At pi over 2 is 0. At pi is negative 1. At 3 pi over 2 is 0. And at 2 pi is back at 1. So the graph of cosine looks a little bit something like this. Okay, and doing exactly what we did with tangent before, we're going to go ahead and graph cotangent, right? So we can actually take this and say, okay, well, let's label this. Cosine is red, sine will be green, and you know what, let's use a different color. Let's use purple for cotangent. So we'll use purple for cotangent. So we can actually go ahead and say, okay, well, if cosine is going to be my my numerator and sine is going to be my denominator, well, let's start at 0. So we have x equals 0, right? And we're looking for cotangent of 0. Well, the cotangent of 0 is the cosine of 0 over the sine of 0, and the cosine of 0 is 1, and the sine of 0 is actually 0. And so what we have here is a fraction in which we're dividing by 0, and so since we can't do that, we can never divide by 0, we're going to have an undefined value. An undefined value in these graphs show up as asymptotes. So here we have an asymptote. All right. Now, right here, I know it's a little bit off, but this should be a point where they're both equal to each other. So when they're both equal to each other, we know that our value is going to be 1. So we're going to have a point right there. Now here we have another value. Okay, so at pi over 2. So now we're looking for the cotangent of pi over 2. And the cotangent of pi over 2, well, the cosine, which is my red one, is going to be 0. So we have 0 over, and then we have sine is equal to 1. So 0 over 1, well, that just equals 0. So down here, we're going to have a point right there. And we can go ahead and do this one, right? We see that we have the exact same point, except that one of them is negative. And so when we have the exact same point, but one of them is negative, we know that we're going to have a value of negative 1. So that point should be right there. And then look at what happens with pi. At pi, cotangent of pi, we have cosine as -1, so -1 divided by, and then sine is 0. So once again, we're dividing by 0, which means we have an undefined value, which means we have an asymptote. And so now at pi, we're going to have an asymptote right here. And you see the pattern repeats. Let me go ahead and erase my sine and cosine so that you guys can see what this will look like. And once we start to connect the dots, and you can see that it's going to look a little bit something like this. It's got a bit of a curve to it. And just like tangent, it's going to repeat indefinitely. Now, let's actually graph tangent. Well, before we do that, let's go ahead and fill in the rest of it. If we follow the pattern, we have 1, and then 0, and then -1, and then at 2 pi, we're going to have another asymptote. So we have another value that looks sort of like this. It repeats indefinitely. At -pi, we're going to have an asymptote. So you notice how there's asymptotes at every pi with cotangents. That's actually super important for you guys to realize. Here we go.
We have -1, oops, -1's okay, 0,
Okay, and so this is the graph of cotangent. It's very, very simple. All we're doing is using the graphs of sine and the graphs of cosine to go ahead and figure out where everything should go. Now, let's go ahead and graph tangents just so that you guys can see what the difference is. So tangent, remember, is the reciprocal of cotangent. So we flip this, right? And let's think about what would happen if we actually flip this. So for example, let's look at cotangent of 0. Well, if we were to flip this, then my value would be 0 instead of an asymptote, right? And then over here, where we have zeros instead, well, instead we would have asymptotes. And down here, well, this is another asymptote, but instead we flip it, so we would have another 0 at pi. And if you will notice that when we take the, let's say for example, the cosine of pi over 4 and the sine of pi over 4. We're looking for this value right here. What is this value going to be? Well, cosine of pi over 4, that's the cosine of 45 degrees, is going to be square root of 2 over 2. And the sine of pi over 4 is also going to be the square root of 2 over 2. And so these two values are going to be the same. So in reality, we're going to have the same point, whether it's cotangent or tangent. But the difference is going to be that since this point is on different sides of this asymptote, while cotangent goes down on the right side, tangent actually goes up on the right side. And so this is the graph of tangent, the one in orange, and the graph of cotangent is the one in purple. And so you see there's a little bit of a difference. Number one, it's shifted. It's shifted pi over 2 to the left or to the right. It doesn't really matter because it repeats. But you can tell that because of the asymptote. See, this asymptote was here and it shifted here. Or you could say that it was here and it shifted here. And also, it's a reflection across the x-axis. So this sort of flipped, right? And so now it's going up on the right or down on the right when it used to be going up on the right. So now let's go ahead and fill in the table of values. So at 0 we had undefined. And just like with tangent, we're going to have important values every pi over 4. So pi over 4, pi over 2, 3 pi over 4, and do the same thing for the negatives. And here, all we need to do is we need to look at our graph and see what values they are. So at pi over 4, we have 1. Pi over 2 is 0. Then we have a -1. Then undefined at pi. And the pattern is going to repeat 1 and then 0. And it's going to repeat exactly the same on this side.
-1, 0, 1, undefined, -1, and 0.
And so you see, it's not that difficult for you guys to go ahead and really just figure this out because of the pattern. It's always going to be a pattern when it comes to sinusoids, or when it comes to any graphs of trigonometric functions. So now looking at the domain, well, we can say, okay, the domain is going to be sort of like tangent, where it's going to be from negative infinity to positive infinity, with the exception of all these asymptotes. So we're going to go ahead and say that the domain is going to be a value of x, such that x is a real number, not including n times pi, where n is an integer. Oops. Where n is an integer. And the reason that, again, we want n to be an integer is because this would include only whole numbers. So 0 is technically an integer. So it would be 0, and then 1 pi, 2 pi, 3 pi, but also negative integers. So -1 pi, -2, -3, -4, and again, it's just going to repeat. The range will be negative infinity to positive infinity. It goes all the way up and all the way down. And the period is going to be the exact same as tangent. It's just going to be pi because it repeats. This right here is going to be the exact same thing that we did for tangent. So this is going to stretch it. So instead of it being at 1, we're going to have a vertical stretch. So this means it's going to go up to 2, and it's going to go all the way down to -2. This right here is going to be my b, which is going to affect my period. So the period is actually going to be a lot shorter. So let's go ahead and look at what is going to happen. So first of all, there's no amplitude. It doesn't look like there's a phase shift. There's no vertical shift. The period, we are going to change that. Important values, we're going to change that. And then the reflection, there's no reflection because it's not negative. So we can go ahead and say, okay, my period is going to be, this is technically 1/3 times x. So my b is going to be equal to 1/3. And my formula for period is, remember, pi over b, not 2 pi because we're working with tangent and cotangent. So we're going to go ahead and say pi over 1/3 is the same thing as saying pi times 3 because we multiply by the reciprocal. So my period is actually going to be 3 pi. So what this tells me is that this is going to be a very long graph. It also tells me that instead of working with a point at 1, we're going to be working with a point at 2. So let's go ahead and label this really quickly. We have pi. Okay, so we know that we have to have a full period from here all the way to here. So let's talk about what we know. Our important values is going to be our period, which is 3 pi, divided by 4. So every 3 pi over 4 is going to be an important value. Now, since that's a little bit weird for us to see here, we're actually going to go ahead and also label the pi's over 4. So this is pi over 4. This is 2 pi over 4. This is 3 pi over 4. So that's going to be our first important value right there. It's going to be 5 pi over 4. And then this is 6 pi over 4. So that's going to be our next important value. So you know what I'm going to do? I'm actually going to go ahead and erase everything that we don't need. So we're not going to need that. We're not going to need that. we are going to need that one, 3 pi over 2. And notice how it's every 1, 2, 3, 1, 2, 3, 1, 2, 3. So we're going to need this one right here. We're not going to need 2 pi. We are going to need 1, 2, 3. This is going to be, you could say this is 9 pi over 4. And then 1, 2, 3, 3 pi, which is technically 12 pi over 4. So again, we don't need 5 pi over 2. So here we have our important values. Let's pick a color, doesn't matter. We can go with red. And we can start graphing. Now, based on the parent function that we have over here, we know that at 0, cotangent is an asymptote. So we have an asymptote at 0. And since the pattern repeats, the end of the period is also going to be the same. At the middle, we're going to have 0. And then at 3 pi over 4, we're going to have a value that's either going to show us a stretch or a shrink. Now, it's going to be, remember, going up on the left, so it's going to be somewhere up here. And this value is going to be 2 because it got stretched all the way to 2. And on this side, it's going to be negative 2 because it got stretched down. So my graph is going to look a little bit something like this. And of course, it's going to repeat on the negative side. And I'm just counting 3 spots. And there we go. This is all you need to know about the graph of cotangent. Now let's focus on these questions. Use a calculator to graph the function, then use the graph of the function to approximate the solutions to the equation on the interval negative 2 pi to positive 2 pi, round to 3 decimal places. So what this is telling you to do is it's actually telling you to go to a calculator, graph it, and then look at the values for x at which tangent is equal to 3. So in other words, what x's will make tangent of x equal 3. So there's actually a very, very easy way to do this. Now, I know a lot of you might not have a calculator at home and maybe you weren't able to download the calculator that I sent you guys, but let's go ahead and look at what would happen if I had access to Desmos, the online graphing calculator. All I need to do is look up Desmos. Okay, now that we're at Desmos, we can actually go ahead and type in tangent of x. And notice how it actually gives me tangent of x, and we can see that it has asymptotes, and we can see that it has the zeros and the ones, and it's just a very, very nice clear graph. This is why I like it. Okay, and now that I have the tangent of x graphed, I'm also going to go ahead and graph y is equal to 3. Now, as you can see, y is equal to 3 will give me this line, and it's going to show me where my graph intersects this line right here, which is why I really like Desmos. So let's go back to my question and see what it's asking me to do. So use a calculator to graph the function. Okay, did that. Then use the graph of the function to approximate solutions to the equation on the interval from negative 2 pi to positive 2 pi and round to 3 decimal places. Okay, so first of all, negative 2 pi is approximately 6.28, negative 6.28, and then positive 2 pi is going to be approximately positive 6.28. So we're looking for values between these two values, all right? So we go back to Desmos and see, okay, well, 6.28 is around over here, so it looks like we have 1, 2, 3, 4, and this is over 6.28, so we're not going to use that one. But it looks like we have 1, 2, 3, 4 solutions. And so we see that the first one, and it's actually already rounded to the first 3 decimal places, is negative 5.03. right? So we can go back and say, okay, well, the first one's going to be negative 5.034. The next one is going to be negative 1.893, my bad. So negative 1.893. Here we have 1.249. 1.249. And over here we have 4.391. And there we go. That's all they're asking for. These are the values approximately for tangent at which tangent would be 0 or would be equal to 3. Go ahead and try this one on your own. You'd follow the same exact thing, of course, instead using the graph of cosine.